this PowerPoint, I'm going to go over engineering overview. So engineering is the application of mathematics and scientific principles to better or improve life. So what do engineers do? They research, develop, design, supervise, and manage. They research, employ basic scientific principles in the discovery and application of new knowledge that will have commercial or economic value. Develop existing or invent new products, discover truths about a subject, and can involve searches in library, manufacturing literature, and patents for existing ideas. And the development is the actual construction, fabrication, assembly, layout, and testing of scale models, pilot models and experimental models for pilot processes or procedures that will work. Does not deal exclusively with new discoveries, but involves using well-known principles and employing existing processes or machines to perform a new or unusual function. Design need to anticipate all manner of problems that the user may create in the application of a machine or use of a structure. You're going to prevent user errors, accidents, and dissatisfaction. Requires a mastery of basic engineering principles and mathematics and an understanding of the capabilities of machines. When thinking about engineering, you've probably heard of the big four. The four fields of engineering include chemical, civil, electrical, and mechanical. But there are so many other disciplines of engineering that are out there. Most of those do fall under like a derivative or a combination of the big four that we just talked about. We'll start with chemical engineering. It applies scientifically the principles of chemistry, physics, and engineering to design and operation of plants for the production of materials that undergo chemical changes during the process. Responsible for new and improved products and processes, new fuels for rockets, reactors, and booster propulsion, medicines, vaccines, serum and plasma, plastics, synthetics, and textiles. Basically, what material is going to be used in the products that you're developing. Civil and construction engineering. Plan, design, and supervise the construction of facilities in both the public and private sectors. Projects vary widely in nature, size, and scope. Space satellites, launch facilities, offshore structures, bridges, buildings, highways, transit systems, dams, airports, irrigation projects, tunnels, treatment and distribution facilities for water, collection and treatment for wastewater. This you'll also find environmental engineering under this discipline. Electrical and electronics engineering. It deals with the motion of electrons in metals. Work focused on large electrical systems, motors and generators, electrical circuits in buildings, power transmission systems, electrical generation plants. Mechanical engineering is the one you probably hear of the most. They apply the principles of mechanics and energy to the design of machines and devices, most often associated with the devices that move. Also, you'll hear of mechanical engineering where people will design products that are going to be used by the public. Even things like soccer balls, footballs, things that you might use every day you'll think of under the mechanical engineering. So aeronautical engineering. It deals with flight and the movement of fluids in the Earth's atmosphere. They specialize in the following work areas: aerodynamics, propulsion, controls, and structure. Aerospace and astronautical engineering. It deals with environments not found on Earth. Specialization in work areas centered on propulsion, materials, and thermodynamics. Agricultural engineering. Agricultural engineering blends engineering knowledge with soil systems, land management, and environmental control. 5 specialty fields: soil and water, food, power machinery, structures, and electric power generation. Architectural engineering works with architects focusing on structural integrity and safety of design. Structural engineering and this field are very similar. The main difference is the concern for aesthetics. Automotive engineering. Design and build all types of vehicles. Automobiles, trucks, tractors, bulldozers, and motorcycles. Biomedical engineering. Bridges engineering, physical, and life sciences in identifying and solving medical and health-related problems. 3 general divisions: bioengineering, medical engineering, and clinical engineering. A lot of people that want to be doctors and are wanting to go to med school will become a biomedical engineer first. Many of the medical schools are looking for those people that are problem solvers and will look at a biomedical engineering degree first over a pre-med option. Computer engineering, the design and organization of computers, hardware and software. Who is the largest consumer of computers today? It's actually the automotive industry. Industrial engineering, the design, improvement, and installation of integrated systems of people, materials, and energy to produce a product at the lower possible cost. It deals with design of systems for the manufacture of products, raw materials to machines, workforce to operate machinery, and removal of finished products. Maintenance of machinery, analysis of manufacturing processes for cost. Manufacturing engineering, design of a manufacturing facility for a product or products. It deals with physical plant layout, use of existing machines or new, purchase of or rental of facilities, purchase of non-producing facilities and equipment, packaging of product, and shipping to the market.